Okay, this is the extra practice to retake the performance task we did from our midterm. So we did this problem before, but it's a good example of the kind of problem you'd be expected to see. So read the questions carefully, understand what you're working with. So it helps to imagine the situation. Imagine an airport, waiting in line, them asking to get people to volunteer to, give up their seat so other people can take them, those kinds of things. It helps to understand what's going on. And if you put yourself in the problem, a lot of times it will make more sense. So when airlines book a flight, they often overbook with the anticipation of having passengers not show up. So a small plane can hold a maximum of 40 passengers. Below is a probability of the total number of passengers that show up for the flight. So that means 5% of the time they had 37 passengers show up. So that means they had 3 empty seats. 15% of the time they get 38 passengers or 2 empty seats. 20% of the time they'll get 39 passengers or 1 empty seat. 30% of the time the plane is full. 25% of the time they have 1 extra passenger than they do seats. Then 5% of the time they have 2 extra passengers than they have seats. So that's just kind of understanding what's happening with the problem. So the first thing we want to do is find the probability that every passenger will have a seat. So we can't go over what we have. Well, these two go over. So because we have 41 and 42. So those go over our maximum of 40. So I can add up all the probabilities right here, and I have a 70% chance of having enough seats for everybody. Another way you can look at it is the way it doesn't happen. There's a 30% chance we overbook. So 1 minus 0.3, 0.7. So there's a couple ways you can look at it. Part B says, what is the expected number of passengers for a flight? And we may want to make sure you show your calculation. Well, whenever you have to calculate an expected number, you take your probability by your value, you multiply them together, and then you add them all up. So I took each one of these, 37 times 0.05, 38 times 0.15, 39 times 0.2, 40 times 0.3, 41 times 0.25, 42 times 0.05. Calculate it out. We expect to have 39.7 passengers. Now the airline makes $600 on every ticket sold for the flight. So that means we're going to be making 39.7 times 600, or 23,820. But if the flight is overbooked, passengers not given a seat will receive a voucher for $800 towards a future flight. If the flight has 41 passengers show up, they need 1 voucher. If 42 passengers show up, they need 2 vouchers. So how much revenue does the airline expect to make for the flight? So even though we've had the flight as overbooked, they still sold those tickets. So they even would have sold them. So that's why we're still using this amount. So we would have made $23,820. 25% of the time we have to do 1 voucher, which costs $800. So we expect per flight to spend about $200 on an extra voucher. 5% of the time we expect to have to need 2 vouchers. So 0.05, 2 vouchers would cost $1,600. So if I take 0.05 times 1,600, it's $80. So my expected revenue is the total we have right here, $23,820, minus $280 for the money they have to spend on vouchers. So they actually expect to make $23,540 on average for this flight. So now I'm starting to wonder, is this a good idea? I mean, one thing, if you overbook flights, people get kind of upset, so it may not be a good marketing idea. But also, maybe they're going to lose money, because ultimately that's what they're trying to do. They're trying to make money. So management for the airline is debating if overbooking is a good practice. They experiment with several flights where the flights were not oversold. So below is the result of the new procedure. Now they also added a policy where the airline also adds a charge of $100 if the passenger misses a flight and has to reschedule. So that means if they have to reschedule, they're going to have to pay an extra $100. So we're assuming that everybody would reschedule who missed their flight. The tickets still cost $600. They will not refund you if you don't show up for your flight. That's a reality. You can go over and you can get a new ticket, but it's going to cost you $100. Should the airline adopt a new procedure? We're going to calculate the expected value with the new procedure. So again, I got to figure out how many passengers do I expect. Because of charging an extra $100, people are more inclined to make it to the flight. So that's why the numbers have changed slightly. Okay, so 5% of the time we have 35 passengers. 10% of the time we had 36. 15%, 37. 20% of the time we had 38. 30% of the time we had 39. And 20% of the time the plane was full. So we're going to look at calculating these out. If I multiply my number of passengers times their probability, I would average 38.2 passengers per flight. So on average, you're going to have 1.8 empty seats. Now the extra fee, well, if only 35 people showed up, 5 people are going to have to pay $100. So that's $500, 5% of the time. Here, 4 people, 10% of the time, had to pay the extra fee. So each one's $100. 400 times 0.1. 3 passengers this time, 15%, so 300 times 0.15. 2 passengers we have to rebook, 20% of the time. Then right here, 1 passenger, 30% of the time. So each time we have a passenger miss it, they're going to have to spend $100. So if I add up all those, I get 180. Now I could have avoided this whole thing, realizing that on average I'm going to be 1.8 passengers short, and it's going to cost $100 for them to reschedule. So if I did 40 minus 38.2, I get 1.8. Multiplied by 100, I also get 180. So that's another way you could think about it. So now, if I want to look at my total revenue, they're going to sell 38.2 tickets on average. That's how much money they're going to get in terms of their seats, times 600, plus 180, gives me a total of 22,920. That was this, plus 180, is 23,100. So right here, they would make 23,100 for that policy. Right here, they make 23,540. So they're better off keeping their original arrangement.